In this video, we'll be talking about inverse trig functions. In a previous video, we looked at the inverse trig relation, arcsine 1/2, and we found that that's equal to 30 degrees. And then if we add 1 revolution to 30 degrees, we get 390. And if we add another 360 onto 390, we get 750. And then we also know that the sine is equal to 1/2 when the angle is 150. So doing the same thing, add 360 degrees to 150, we get 510. And add 360 degrees to 510, we get 870. Now if we limit the answers to one value, then it'll be an inverse trig function rather than a relation. So let's look at the limitations for inverse trig functions. If the ratio is positive, then we want to pick our angle in quadrant 1. Now we know also that the sine is negative in these two quadrants. So if our ratio is negative, we'll use the angle in quadrant 4. So for arcsine, we're limiting ourselves to angles that are between negative 90 and 90. So just these two. Now for arc cosine, if our ratio is positive, again we'll use our angle in quadrant 1. Cosine is negative in quadrant 2 and 3, and we don't use quadrant 3, so our angle will be chosen from quadrant 2. So we'll just use these two from 0 to 180. And then for arctangent, if our ratio is positive, again we'll pick our angle in quadrant 1. If our tangent ratio is negative, we'll pick our angle from quadrant 4. So our arctangent is limited to these two quadrants, 1 and 4. And so the angle will come from the interval negative 90 to 90. Now notice on all of these inverse trig functions, I used a capital letter here. Usually when you talk about inverse trig functions, that's all you talk about. You don't deal with the relation because there are so many answers when you have a relation. But for right now, when we want to tell the difference between the two, let's go ahead and use a lowercase beginning letter for the relation, which has a lot of answers, and then uppercase beginning letter for the function, which is limited to these quadrants. And let's do an example. We're asked to evaluate arcsine root 2 over 2. So we want to find the angle whose sine is root 2 over 2. If you don't recognize this as the ratio of one of our special angles, you may want to unrationalize the denominator. So we can do that the same way we would when we rationalize the denominator. Let's multiply top and bottom by root 2. So basically we're rationalizing the numerator. So we get 2 over 2 root 2, and then my 2's will cancel, and I'll have 1 over root 2. So now my problem is to evaluate arcsine 1 over root 2. So I'm looking for the angle whose sine is 1 over root 2. Now this ratio is positive, so I'm going to be in quadrant 1. Anytime your ratio is positive, your angle will come from quadrant 1 for the inverse function. So in quadrant 1, my sine ratio is defined as opposite over hypotenuse. So my opposite side is 1, and my hypotenuse is root 2. Now you should recognize this as 1, 1, root 2, or a 45, 45, 90 triangle, which means that my angle here is going to be 45 degrees. So arcsine 1 over root 2 is 45 degrees. Let's do another one. We're asked to evaluate the arctan negative 1/3 root 3. So we want to find the angle whose tangent is this ratio. Now I'm going to first multiply this and get a single ratio. So that would be negative square root of 3 over 3, because you multiply the 1 times the radical 3. And then let's go ahead and rationalize the numerator so that this looks more familiar. So I have a negative root 3 times root 3 is 3 over 3 root 3. And again, I can simplify here, cancel those 3's. So I have a negative 1 over root 3. So my problem now is to evaluate arctan of negative 1 over root 3. So I want to find the angle that has a tangent ratio of negative 1 over root 3. Now for a negative ratio, I need to limit myself to this quadrant, quadrant 4. The tangent ratio is defined as opposite over adjacent. So my opposite side is going to be 1, and my adjacent side is going to be root 3. Now you're probably wondering about that negative. This value is positive since it's going to the right here of the y-axis. So my negative is going to go with the 1. So now I can recognize this as a 30, 60, 90 triangle, and my angle here is 30. Now you may be tempted to give the angle as 330 degrees, but let me point out again that our arctan is limited to numbers between negative 90 and 90, and 330 is outside of that interval. So I need to write my answer as negative 30. And let's just make a note that that's not 330, since arctan is between negative 90 and 90. Let's do one more example. In this problem, we're asked to evaluate the cosine of arctan negative 3/5. So we're wanting to find the cosine of the angle whose tangent is -3/5. As usual in mathematics, we need to work from the inside out. So let's go ahead and evaluate this first. Arctan -3/5 is going to be an angle in quadrant 4, and our opposite side is -3, and our adjacent side is 5. Now we really don't need to find the angle because our problem continues on to ask us what is the cosine. Well, this is our angle right here, but we don't need an actual value for that angle because all I need is to find the cosine ratio. The cosine ratio is defined as adjacent over hypotenuse. So my problem still remains to find the value of the hypotenuse here. I can use the Pythagorean theorem. Let's call this R. So I would have 5 squared plus -3 squared equals R squared. 25 plus 9 equals R squared. This is 34. So we have R is the square root of 34. Let's write that in up here. Square root of 34. So now I can find the cosine of this angle. This angle, remember, we showed it as theta. So the cosine using our diagram is going to be adjacent, which is 5, over the hypotenuse, which is root 34. And then the last thing that we want to do is rationalize this denominator. Multiply top and bottom by root 34. So we have 5 root 34 over 34. So let's recap. It's important that you remember the limitations on our inverse trig functions. For all of the inverse trig functions, if your ratio is positive, your angle will come from quadrant 1. So this is when we have a positive trig ratio. We'll use angles in quadrant 1. Now the only time that we use quadrant 2 is when we have arc cosine. When our cosine ratio is negative, then we'll choose our angle in quadrant 2. For the other two, for arcsine and arctangent, and when our sine ratio is negative, we'll pick our angle in quadrant 4. And when our tangent ratio is negative, we'll pick our angle in quadrant 4.